What if the airplanes of the future don't burn a single drop of aviation fuel? Imagine boarding a plane that takes off almost silently, powered entirely by electricity. Electrical aviation, the invention that could change humanity flights. Imagine boarding an airplane in the future. You sit down, you fasten your seatbelt. The aircraft begin moving towards runway. But instead of the familiar roar of a jet engine, you hear something very different, almost silence. Electrical motors begin turning the propellers, and aircraft accelerates and quiet rise into the sky. No burning jet fuel during the flight. No traditional engine roar. This may sound like science fiction, but electrical flight is already a reality. And in 2026, a major new milestone has brought electrical aviation one step closer to the commercial reality. So, how did humanity begin to fly with electricity? How does an electric airplane actually work? And could this invention change the future transformation in the economy and even the way of human living? Let us find out. The beginning of electric flight. Electric aviation is not actually a new idea. The first crewed electric aircraft flew more than 50 years ago. In 1973, the Milky MV-E1, a modified motor glider, flew using electricity stored in batteries. The flights lasted only about 9 minutes. Compared with today's passenger aircraft, it was extremely limited. But that short flight proved something important. An aircraft could fly using electricity instead of a conventional combustion engine. Since then, engineers have experimented with batteries, solar power, electric motors, and hybrid propulsions. NASA also developed the X-57 Maxwell, an experimental all-electric aircraft designed to investigate a technology such as electric motors, batteries, and distributed propulsions. Although the X-57 program ended without achieving its planned flight, NASA says the project produced valuable lessons about batteries, electrical system motor controllers, and electrical propulsions. So the journey towards electric aviation has been going on for decades. But now something has changed. The technology is becoming much more powerful. The new electric aircraft. In August 2026, Heart Aerospace announced a major milestone. Its X-1 demonstrator successfully completed its first flight. The aircraft is more than 100 feet across and weighed more than 25,000 pounds at takeoff. It is being used as a technology demonstrator for company's future hybrid electric region aircraft. This is important because the aircraft is operating on a scale much closer to commercial aviation than many earlier electric demonstrators. The X-1 is not the aircraft that will suddenly replace every Boeing or Airbus. Instead, it is part of a much larger experiment. Can electricity become a practical source of propulsion for passenger aircraft? And the answer increasingly appears to be for some type of aircrafts, yes. How does an electric airplane work? The basic idea is surprisingly simple. A conventional aircraft burns fuel. The fuel powers an engine. The engine produces mechanical power. That power turns to propeller or drives a fan. An electrical aircraft changes the first part of this equation. Instead of carrying large quantities of aviation fuel, the aircraft carries batteries. The batteries send electricity to electrical motors. Motors turn propellers, and those propellers create thrust. Electrical motors have another major advantage. They can be highly efficient compact and mechanically simpler than the combustion engines. Engineers can also distribute multiple electrical motors across an aircraft wings. NASA's X-57 concept, for example, used multiple electrical motors and propellers to investigate how distributed electricity propulsion could improve aircraft efficiency. This opened the door to completely new aircraft designs. But there is one enormous problem. The biggest problem: batteries' weight. This is the biggest obstacle facing electric aviation. Aviation fuel contains a huge amount of usable energy for its weight. Batteries are much heavier for the same amount of stored energy. And there's a critical difference. When an airplane burns fuel, the fuel gets lighter as the flight continues. A battery does not. The aircraft carries almost the same battery weight from takeoff to landing. This is why today's battery electric aircraft are much more suitable for shorter regional flights than long distance international flights. NASA has highlighted battery weight and energy density as fundamental challenges to large-scale electricity aviation. So don't expect a fully battery-powered aircraft flying from Mumbai to New York anytime soon. The first major revolution is much more likely to happen on shorter routes. The future. So will electric aircraft replace today's airplanes? Probably not all of them. Instead, aviation could become a mix of technologies. Small regional aircraft could become fully electric. Larger regional aircraft could use hybrid electric propulsions. Sustainable aviation fuel could power some long-distance aircraft. Hydrogen could eventually become another possibility. And conventional aircraft may continue to operate while these technologies develop. The important point is that the transition has already begun. More than 50 years ago, an electric aircraft stayed in the air for only minutes. Today, engineers are testing much larger electric aircraft and developing systems for commercial regional aviation. The aircraft also of the future may be quieter. The energy system may be cleaner. Airport may become energy hubs. New industry may emerge. And aviation could become accessible to more communities. But the biggest question remains: can humanity develop a battery powerful enough light enough to serve enough to electricity the skies? If we can, we may not simply be inventing a new airplane. We may be beginning a new era of human transportation. The future of aviation may not be powered by the fuel we burn, but by the electricity we create. The electric sky is no longer just an idea. It has begun to take off. Questions for the future. More than 100 years, aviation has depended on one basic formula: burn fuel, create thrust, and fly. Now engineers are trying to create completely different formula: store electricity, power electric motors, and fly. The aircraft may become quieter. The energy system may become cleaner. The economics may change and entire industry could be transformed. But there is still one giant question: can humanity build a battery powerful enough and light enough to truly electricity in the sky?